Audio Jungle. Audio Jungle.
Right. So you had seen that Routh discriminant, all the cases are greater than 0, are less than 0, are equal to 0. And also you had seen that constant E is equal to 0, then what will happen? Now, moving to the next, here it is nothing but we have to discuss the time period because we are talking longitudinal dynamic stability, LDS. So in LDS, longitudinal dynamic stability, basically we have two modes, no? Two modes of oscillation in LDS. Check everybody in LDS, two mode of oscillation we have. Two mode of oscillations we have. What are that two? That two are nothing but it's a short period oscillation SPO, then long period oscillation LPO. Correct? Long period oscillation LPO also called as phugoid motion. Phugoid motion. Okay. Right. So obviously, if I'm talking about the short period oscillation or long period oscillation, so we need to discuss what is the time period and how to calculate. Basically, here, okay, in this situation, characteristics equation and all is given to you. Then how you will calculate the time period? Okay, so that you have to write. Correct. So what is the time period? You please write down that mathematical formula. Time period. The oscillation, how you will calculate time period. It is denoted by capital T, right? T, it is denoted by T, and the formula you need to write, okay, directly. So T is nothing but, check everybody. It's a 2 pi T bar divided by Q. Divided by Q, correct? Right, Q. So you should write here what is the T bar and how to calculate. So T bar is nothing but, first of all, it will be given to you. If it is not given, then you just write down. It's a m divided by rho vs. M divided by rho vs. Correct. M is nothing but mass of airplane. Mass of airplane. Okay. And rho is nothing but free stream density. Free stream density. Correct. V is nothing but free stream velocity. All data will be given to you. Free stream velocity generally be in infinity. Correct. Free stream velocity. And S is nothing but wing area. Check. S is nothing but wing area, right? And what is the Q? Q, as I have already told you, if you remember, P plus IQ. This is the complex root. This is the complex root. If you solve the characteristics equation of the dynamic equation, so you will have a roots. I mean, four roots you will get. Few maybe complex pair, few may be real or imaginary kind of things you will get. Okay. So Q here in this situation, Q is nothing but the imaginary part of the root. Check, P is the real, and Q is the imaginary, right? So you can say imaginary imaginary, okay, part of root, right? Always remember this T bar sometimes asked to you. It is called airplane density factor. What it is called? Airplane density factor. Airplane density factor, correct? This formula is very very important here. Now this is all about the time period. Now it is also sometimes uh, important. They will ask time to time to half of the oscillation. So time to half, how you will calculate? Time to half, how you will calculate? That is also one parameter you should know here. Correct? So that I will write here, time to half. Time to half, maybe positive half or maybe negative half. So that will be nothing but denoted by time to half means t 1 by 2, 1 by 2 of the cycle. So mathematically it is nothing but 1 by 2, it is nothing but minus of 0.693 t bar divided by p. Everything you know, okay, only one is unknown because t bar already I have shown you. It is nothing but airplane density factor, and t bar is also given by m divided by rho vs. That already you have seen, huh? Only p is new here, and that also you are aware with this p is nothing but the real part of the root. Just like a q is the imaginary part, check, q is the imaginary part. So similarly p is nothing but the real part of, that's all, real part of root. Now, if it is asked to you, what is the third number here? This is the second parameter. Third parameter they can ask to you, number of cycle to half. Number of cycle to half. So how you will calculate 1 by 2, right? So n 1 by 2 is nothing but obviously natural frequency will be given to you into t of half. Huh? Fn is nothing but natural frequency. What is the Fn? Fn is nothing but natural frequency. As usual, simple symbol here, Fn. Fn is nothing but the natural frequency. How to calculate this natural frequency? It will be C Wn by 2 pi. Wn also a natural frequency. Fn is also natural frequency. Only difference is Fn you will measure in hertz and Wn you will measure in radian per second. Correct? This is the thing only. Now I will give one problem, okay, and we'll discuss that problem. Okay, so you will understand. You will understand here, correct? Right. So see this problem. So we are talking the problem one. Okay, please write down this. The quartic equation. Quartic equation of equation of longitudinal longitudinal dynamic stability LDS of an airplane of an airplane is given as, okay, lambda square plus 5.0159 lambda plus 12.984 in one bracket. Okay, another bracket, lambda square 0.03 406 lambda plus 0.045 is equal to 0. This is the equation. Quartic means fourth order or power, you can say, just like a cubic equation, quadratic equation. Similarly, we have a quartic equation, correct? So see, if you open the bracket, lambda square is here, lambda square is here, you automatically you will get the lambda power 4. For this particular equation, what they have asked, calculate, they are asking first time period. They are asking then time to half, time to half, which is nothing but t 1 by number of cycle half. Okay. Fourth, identify, identify, identify the modes. Modes means I told you, basically in take case of the LDS longitudinal dynamic stability, we have a two modes, short period and long periods. To identify the modes also, because you will get the roots. So with the help of roots, how you would know this is for the short period oscillation and this is for the long period or phugoid, correct? That you should know how to identify. That is the main motive. Identify the modes, and 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 fifth one is nothing but damping factor. I have already given the formula how to calculate the damping factor, and then six number is nothing but, this is the fifth. Six number is nothing but it's a natural frequency. Huh? So that natural frequency, obviously, it will be in the hertz or you can say in radian. It's your choice. Natural frequency. Correct. This is the problem. Think about it. If they will give the problems, such type of problem, and you are going to calculate the roots for this, because without root nothing can happen. I mean, without roots you will not able to proceed the problem. You will not proceed the uh, solution of this problem, correct? So because all the, if you see the route discriminant there, I had given all the cases, okay? And for all the cases it was explained, when root will be positive, this will happen, when root is what negative, this will happen, something, all the information I had given. So the point is, for such type of problem, if you are going to calculate roots in your examination, it will be very difficult task. So think practically. Such type of problem they will be asked to you? No, they will not ask such type of problem. The point, not such type of problem in the sense, this characteristics equation they will not ask to you. They will give the characteristics equation if, then they will give the roots also, otherwise directly they will give the roots. So it will be very easy for you, okay? It will be very easy for you. That's the reason you have to practice hard this such type of problem, okay? Question will be asked to you, because recently if you see last 10-year question paper, not one time, multiple time question has been asked from here, okay? Anyway, so such type of equation, if they will ask to you, so they will give the root, because finding the root itself a very big task. It will take so much time. So roots will be given to you. That is my point. So now here I will show you how to calculate the roots. It's very easy. Even though If you are going to calculate also, easily you can find it, if you have good calculation. See, this is the one part here, this is the one part, this is the another second part, two parts we have, okay. And both, you see it is in bracket, so both are in product. So maybe first part is 0, maybe second part is 0, correct or not? And obviously it is in product, so maybe both is what 0, possible, correct? So if first part is 0, then what you will write? You will write lambda square, check, lambda square, lambda square plus what they have given, lambda square plus 5.0159 plus lambda plus 12.984 is equal to 0, correct? Because in product and is equal to 0, you can take lambda square plus 5.0159, okay, 59 lambda plus 12.984, because it is in one bracket, and another bracket also is there, and it is equal to 0. So maybe this first part is 0, maybe second part is 0. So you are putting this first bracket part is what 0, it is in bracket, correct? So then right, it is in, this is the first part. So if you put equal to 0, so now it becomes quadratic equation. So you know how to solve such type of equation. You use, because it is in format of what, ax square plus bx square plus c. Sridharachar, you can apply and you can get the root. Okay, so that you can do. It is easy now for you. So here I'm just giving the roots for this particular solution. Okay, but you can apply this Sridharachar and you can get the root. So what will be the roots for this? I will write here. So it's nothing but lambda 1 comma 2 is equal to minus 2 point. I just want to save the time, for that reason I'm just giving this solution, I mean roots, giving to you. Okay, otherwise you easily you can calculate it after applying the Sridharachar. Plus minus, plus minus, it's nothing but I, that is the imaginary 2.587, 0.587. This is the roots basically. See, they have given lambda 1 and lambda 2. What is the mean of it? If you see, if you open this, so you will have a root, lambda 1 is nothing but minus of 2, minus of 2.508, 508, 2.508 plus imaginary 2.586, and lambda 2 will be check minus of 2.508 minus imaginary 0.58, the mean of these two roots. I hope you all are agree with this. Correct. Similarly, if you take the second component, see, second component means this part, no? That also you make it 0. So what you will get? Then you will get lambda square plus 0.034, okay, 06 lambda plus 0.0, okay, 454 equal to 0. Again, you just apply Sridharachari for this, and then ax square plus bx plus c equal to 0. Correct? So again, you will get the roots for this particular. So what will be the roots for this solution, for this quadratic equation? The solution will be again, because lambda 1 2 already you have written. So it's your choice if you want to write lambda 1 2, or in few books it will be written lambda 3 4 also. So nothing to worry, that will segregate separately, we will write. Okay, so again for this particular also I'm just going to write the roots, which is nothing but lambda 1 2, correct? You can write here for this equation also, you can write lambda 1. Generally in, just you can write lambda 3 4 also, but it's your choice. This is also lambda 1 2, is nothing but minus of 0 point, please write properly, minus 0.017, okay, plus minus I of 0.2125, right? What is the mean of it? The meaning is very simple here. Lambda 1 is nothing but, you can say it's a lambda 3 now, which is nothing but minus 0.017, okay, 0.017 plus you have to write imaginary part 0.2125, and lambda 4 is nothing but for this lambda 2, because here it is not given like a simple equation they have given, so we can assume lambda 1 2 also, that will not be wrong. So here that value is nothing but minus of 0.017 minus of imaginary 0.212. This is the correct. You see the both the roots are complex with negative real part. Now you just go to your notes and check if the roots are complex with negative real parts, what it will be representing. See it. Both roots in, yeah, because if you check the roots, so how many roots you got? Basically, you talk two roots, but it's a pair of two roots. You can say how many roots you have? Pair of two roots. Check it. It's a pair of two roots. Pair of two roots means lambda 1 2 it is plus minus, so that is the one pair, and second pair is this one, lambda 3 4, you can say. So lambda 3 4 is one pair, huh? And lambda 1 2 is one pair, so two pair of roots or pair of two roots uh, you got here. Now you see your, check your notes. If you see your notes, it was given to you that if the roots are complex with negative real part, then it will be representing the, say, damped oscillatory motion. Check negative real part. Somewhere it is given to you. Last class, if you see the notes, check your notes. Somebody have written, huh? Yes or no? Check. Somebody has written this. Two roots, pair of two roots is given. Check. Pair of two roots. Pair of two roots is given. See here. It will be here only. Souths, correct. Pair of two.
Case 3 and case 9.
Where the positive
Case
real
3.
part is 3. Case 3. Good. Check routes. So anyway, we'll check the routes a constant also that also you can check. Dynamic is stable. All the modes are periodic and damped. Then the roots of characteristics equation will be complex pair with negative real part. If it is, then that basically that will be the stable, and all the modes are periodic and damped. So periodic means oscillatory. Periodic means oscillatory motion, and that oscillatory motion will be damped oscillatory motion. Damped oscillatory. Okay? You please remember this. Anyway, and if you want to check the Raoult constant here, so what you will do, you just convert this equation. I mean, both bracket you just open, multiply, and you just write in this format: lambda power 4, lambda power 3, lambda square, and lambda. And check lambda power 4, that coefficient will be A, lambda power 3 coefficient will be B, C, D, E. Similarly, it will be there. And this A, B, C, D, once you will have, then you will use this Raoult criteria, which is nothing but Raoult's constant, that is capital R BCD minus D square A minus B square E. If you do and if you calculate that, okay, then ultimately R greater than 0 you will get, 100% you will get. Okay, because see one case, because what we had done first, we had calculated Raoult's constant there, and then for that Raoult's constant, if it is R greater than 0, then all 4 points I had given to you, right? But now what we are having here, without calculating Raoult's constant, we got the roots value. So through the roots we got that yes, it's a complex pair roots, it's a complex pair roots, and also the real part of the roots, here it is nothing but negative, so automatically it is now fitting in case 3, and case 3 was the Raoult constant R greater than 0. So any kind of question they can ask to you, simple. One more thing, without, see this lengthy problem I had given. Now if suppose this is the gate question, suppose if it is a gate question, so what they will ask directly, they will give this equation. Okay, they will give equation for 2 marks, and simply they will ask, it is a damped oscillatory or undamped oscillatory, it is a stable or unstable. This characteristics is correct, this character characteristics equation describes damped oscillatory, option A, undamped oscillatory motion, option 3, dynamic stable, option 4, dynamic unstable, kind of things they can give. Okay, so that time your sense should work. So that time what we will do, without doing anything, simply just open this bracket, just multiply, convert into the standard characteristics equation, that is the a lambda power 4 plus b lambda power 3 plus c lambda square plus d lambda plus e is equal to 0. And immediately you will have a abcd, just compare with your standard equation. Once you will get the standard characteristics equation after comparing abcde, once you will have abcde, immediately you just put in the Routh's constant, that is nothing but capital R. What is the capital R? BCD minus D square A minus B square E. And check R is less than 0, R is greater than 0, R is equal to 0. All those things you have to check. So if you check for this particular case, you will get R greater than 0. That means Routh's constant is what? Positive. If Routh's constant is what? Positive. So if you had to check, in your case 3, I had given Routh's constant, if it is positive, then obviously it will be the periodic damped oscillation. Whatever the options will be given, you can mark that. I hope you understood this. Okay, so the gate question will be asked like that only. They will not ask these all 4 5 points. Simply just for practice, I'm solving this. Okay, I hope you understood. Right, now we'll be solving this problem. Okay, so it is very clear. We can write also for this particular problem after looking that roots. That roots you have seen, it is nothing but the roots, pair of the two complex roots, and pair of two complex root, as well as it's a with negative real component, with negative real part. So you can write uh, as the both, as the roots are, as the both roots are complex pair with negative real part. Negative real part. You have seen with negative real part. Check both. Now you tell me plus minus. Boris, what is the lambda 1 2? Say, what is that lambda 1 2? First part. Roots, tell me what is that? Lambda 1 2 minus.
minus 2.508,
Okay,
2.508
right.
plus minus
Huh? Imaginary.
iota 2.587
And say this lambda 3 4. What is that?
minus 0.17
2.017 plus minus iota
plus minus
I 0 point.
0.2125
Right. So you know very well.
2125
2 1. Correct. 2 1 2 5.
2125
Okay.
25
So this is nothing but the real. Right. And see, this real is nothing but what? Negative. So it is satisfied with the case 3. This is the case 3. Okay. Satisfying the case 3. And you know, the case 3 is nothing but, check. Case 3 is nothing but, you can say here, it's nothing but the damped oscillatory motion. And first you had seen dynamic stable, case 3. If it is happening, then it will be a dynamic stable. Okay, it's second point also. Automatically, if you say dynamic stable, it means it is a dynamic, sorry, damped oscillation, not dynamic. Anyway, they have written. So you can write damped oscillation. Damped oscillation. If it is now damped oscillation, or dynamic stable. So two modes you will have. Two modes you will have. For this case, two modes you have. What are that? Say it's a short period oscillation. It's a long period oscillation. This is done, right? Now for the short period oscillation, how you will find this one is the short period oscillation and this one is the long period oscillation. How you would know? Even though that time when I had explained that time I had given to you how you would know, but another method also we have. Okay, now I will show you. Check. Please concentrate here. Huh? Please concentrate now. So I have segregated, so you will not confused. First bracket, whatever roots you got, it is lambda 1 2, and for the second bracket, this is the lambda 3 4. So now you will understand. Now see, if you check for the lambda 1 2, check for the first bracket, lambda 1 2 is nothing but minus of, please concentrate, minus 2.508, okay, plus minus, plus minus imaginary 2.587. You have to compare this, okay, you have to compare the same thing, you have to write lambda 1 2, okay, that is nothing but the standard, it is minus of, in vibration I had taught you damped oscillation, under damped if you remember, minus xi omega n plus minus damped, and last class also I had told you plus minus, it's a imaginary part of the damping frequency, damping natural frequency, which is nothing but wd, and you know very well what is the wd, damping natural frequency. It's nothing but, if you remember, wn root of 1 minus, say, chi square or zeta square, correct? So you keep it, na? So it's nothing but minus of chi or zeta omega n plus minus I wd is nothing but omega n root of 1 minus zeta square. Check it. Check everybody. Now, if you compare with this, okay, if you compare this chi omega n is nothing but, with minus sign already it is there, so it will be 2.508, equation number 1, and second, omega n root of 1 minus chi square in root is equal to 0.586. This will be equation number, correct, equation 1 and 2. You have to solve equation 1 and 2. See, chi omega n is equal to 2.508, and wn minus root of wn root of 1 minus zeta square or chi square is equal to 2 point, just compared, just compared with, okay. So obviously two unknown, two equation, chi omega and two unknowns and two equation you have to solve this two equation, then ultimately you will get this is 0.6, okay, 961, and omega n you will have 3.609. That will be obviously natural frequency, but in radian per. Now I had given to you that time period. What is the time period? Time period, if you calculate, so it is nothing but 2 pi divided by wn, which is nothing but what it is called, natural frequency. So if the natural frequency is what high, then your time period will be less. That's the mean of it, right? If this is high, then time period will be less. Now if time period is less, then what it is called? Say if time period is less, it indicates uh, smaller time period. Smaller, you are using this word smaller, so means you are comparing with others, so that another bracket value also you have to calculate, and then you have to compare. So you will get that, I will show you, you will get that this value is what is smaller, so indicates a smaller time period, means Smaller time period, what it is called? Say, what it is called? SPO or LPO? Okay.
SPO.
Very good. That means it's a SPO. So now just think the pattern of the exam, GATE exam, how it will be asked. They will be given routes directly. I will show you 2 marks question they had asked, and direct routes has been given to you. From the routes only you have to find, yes, this is the SPO and this is the LPO. That was the question only in GATE, 2 marks. But here I have shown you all the pattern, all the process, all the from initial to this. I have shown you how to calculate the roots and all. But in examination, roots will be given to you. Simply you have to identify the case 1, case 2, case 3, case 4. According that you can mark, yes, this is dynamic stable, this is dynamic unstable kind of thing. That is the one type of question they are asking. And second type of question, they will give the routes, they will give the roots, and from the roots you have to find this is SPO or LPO. Khatam. This is the only things they are asking in examination. Okay, that is the one. Anyway, and also if natural frequency is what high, that means time period is less. Time period is less means obviously it's a SPO, short period oscillation. It is called short period oscillation. I will show you how to mark answer directly without calculating anything. Okay, first let me calculate uh, the another bracket. This is the short period oscillation. Okay, now we just focus on the second bracket. Now tell me what was the another roots. Second root. What was the second roots? Roots pair. I must say pair. So it's nothing but lambda 3 4. Can you tell me what is the lambda 3 4? Yes, what is the lambda 3?
Minus 0.1017.
Minus 0 point.
0.017
Okay, plus minus.
plus minus 0.
Yes. 0.2125, right? Check. Agree? Everybody. Again, you have to compare. Again, you have to compare with minus of zeta omega n plus minus omega n root of 1 minus zeta square or chi square, whatever you can call. Correct. Again, two equation you will have. Okay. See, you will have check chi omega n is nothing but 0.017, number one equation. Number two, is nothing but 0.2125. This is the equation number. So if you solve this there, okay, if you solve this, so you will get zeta value separately, and you will get the omega n value separately. So what zeta you will get? You will get 0 point, right, 0.798. Correct. 0.0798, and the second one you will have a omega n value, that will be omega n. Omega n is nothing but you will get 0.213 radian per second. Okay, you will get this. Think about it. Now, if you see the omega n is nothing but, I'll take another page. So t is nothing but 2 pi omega n. See, omega n value compared to the previous. Earlier the omega 1 n was, see the omega n. Omega n was higher value, 3.602. I told you smaller means you are comparing with others. So omega n here if we have a 3.6. But if you check this omega n, we are having only 0.213. So obviously this in this case omega n is what high, as the reason smaller time period. But in this situation here, omega n is very less. Omega n is what? Very less. So this time period will be larger. So indicates
Long period such.
Yes, yes, indicates larger time period or longer, no? Better. Anyway, so this will be LPO, long period oscillation, which is also called phugoid. Phugoid. Okay, so in single problem, multiple types and multiple number of problem you are solving. They can ask 4 5 question with this problem only. First, they can ask what the type of the, I mean, it's a stable or unstable, it is damped or undamped kind of thing they can ask. Second, they can ask the, by swing by looking the roots, they can ask what type of the mode. I mean, two modes you have, but it is SPO or LPO that they can ask to you. Third, based on the Rouse criteria R, they can ask to you. So you just follow the instruction what I am giving for this, because this subject itself a very big subject. Stability is not a simple subject. I don't say it is very difficult. Actually, there is nothing difficult if you are giving time for any subject, long time if you are learning and practicing. So any subject can be very easier, and if you are not giving time to that subject, so that subject will be the one of the most toughest subject. That is the rule of study. If you are giving time, it will be easy for you. If you are not giving, it will be very difficult or very tough subject. So but yes, this stability compared to others, definitely, uh, comparatively, it is difficult, I must say. Not because of that, because the people are not giving time, for that reason. So I would say it is very precise. Don't go for the Nelson and all for very, because I have prepared my notes from Nelson only. So what is the material, the outcome, the takeaway I am giving to you. If you go for the each and everything from Nelson, then you will be very in difficult mode, because so much things they have given. But as per your gate requirement, this notes I have taken from Nelson only. Okay, so because that is the one of the best book for the stability and control, Nelson, right? So anyway, here, hope you understood, right? So by seeing the roots, by looking the roots, how you will correctly say, I will tell you one thing. See, it is very clear that if you check the roots, okay, any roots you can see. I'll show you first one. Check what is the because this is nothing but 2.508 and this one is 2.587. This is the WD. Think if you compare, this is nothing but WD. WD high or low. If WD is high, then time period will be less. Correct? Directly. Because WD itself a natural frequency, but damping frequency. It's a damping frequency, but that also natural frequency. Damping frequency means there is a damping oscillation. So for the damping oscillation, that frequency will be called as a WD, the damping frequency. Okay, but it's also the natural frequency. But for the damped oscillation, this is also a natural frequency. So directly by seeing that, if WD is very high, that means time period is less. Directly you can say it's a SPO. That is one thing to understand like this. Second, how you will understand by seeing that first part, because WD is what high. So WD have a two component, WN and zeta, right? So by seeing this, you can say W and zeta we have. Okay, W and zeta we have. So this number is what high means, because zeta is directly multiplied with this. Okay. So if this number is what high, 2.508. So comparatively, zeta will also be high number. Check it. Zeta, see, 0.6961. And the last one, what is the zeta you have calculated? Just let me go back here. This was second. Here. What is the value of zeta you have calculated here? Check. Where is the zeta for this? What is the value of zeta you have calculated? Anybody can tell? What is the value of 0.69? That is for the SPO, right? And for the LPO, check zeta is 0.0798. Very small. Compared to LPO, they check the zeta. LPO zeta is nothing but, sorry, SPO zeta is nothing but 0.69. For LPO zeta, if you check, this is the LPO zeta 0.07. What is the mean of it? If zeta is high, what is the meaning of it? Zeta is the damping factor or damping ratio. If zeta is high means damping ratio is high, damping factor is high. What is the zeta value in vibration? Because same, it is also the same formula. It is also the vibration only, right? What is the zeta formula, if anybody remember? What was the damping ratio? Anybody? Very good. C by CC, correct. So automatically you can say C is nothing but which is the damping coefficient, which is responsible for the uh, damped oscillation, which is responsible for the decaying the amplitude, this damping. Because if you draw this the spring and damping coefficient mechanism, so it is just like this. See, check, like this only. This is mass, this is K, and this is nothing but C. So this is just like a soccer in your bike, just like a soccer in your bike. सॉकर अच्छा नहीं काम करता तो आपको प्रॉब्लम होता है, जर्क लगता है ना, बिकॉज जैसे ही कहीं गड्ढे में गई बाइक और कार ना, तो ऑब्वियसली जो जर्क डेवलप होगा, तो ये सॉकर क्या करता है, एब्जॉर्ब करता है, तो वो मोशन को बहुत स्लो मतलब अप डाउन करता है, जिसकी वजह से आपको जर्क लगता नहीं. तो इट्स जस्ट लाइक अ शॉकर इन योर बाइक. सो थिंक इफ दिस सी इज व्हाट इज स्ट्रॉन्गर, so zeta cc, huh? That my point is, if zeta is stronger, okay, is higher, zeta is what higher value, so c will also be higher. If c is higher, then whatever the oscillation, this oscillation will uh, that amplitude will decay faster, or oscillation will be decaying faster. I hope you understood my point. So if it is decaying faster, so that time period will be smaller because it will slow the oscillation. Hope you understood, because of the damping coefficient. So obviously it will be the smaller time period, then so it will slow down that. And if C is what weaker, I mean the value of zeta is less, so C, this damping coefficient is not a higher value, it is a smaller value, so it will allow more faster oscillations. Obviously time period will be. Hope you understood, correct? So in this way you can understand, you can relate that. It's your choice, two way you have. By understanding you can say, otherwise you just calculate zeta and wn, and then directly you can, after calculating wn, you can say yes, it is the smaller time period, or that uh, longer time period, lpu. It's your choice. So this is the one way they can ask question, okay? Anyway, now moving ahead to the next, that is now simple, it's formula based now. Okay, so how to calculate that the value of time period? Now it will be easy for you. See, time period, because they have not given the any value for like velocity or density. So definitely that air density factor, so you have to calculate in terms of the air density factor only. So time period, so what is the time period t? That formula, time period t is nothing but 2 pi, check the formula, 2 pi t bar. T bar is nothing but the airplane density factor, correct? T bar is nothing but airplane density factor. So you need to write your answer in terms of t bar only, because that information they have not given. Mass, density, velocity, wing area, they have not given. So what is the time period? 2 pi t, and divided by what? If you remember, it was q. Was q, correct? So that value you have to write for the first one. So I will say first one means it was, if you see, it was the SPO. Agree? Check, it was SPO. First one was the SPO. Am I right or wrong? Check. Yes, first was SPO. And second also you have to write for the LPO. So in both only the difference will be the Q. So both formula I am just writing. You please write that value of Q. So you will get it. Anyone, please say that value. You take
2.4275.
2.4275 T bar, and here,
75.
yes, here, here
29.5529.
0.55.
5529.
Now check both. See, time period is very less, so that's the reason it is called SPO, short period oscillation. Time period is very high, 29, as compared to at least this. So that's the reason it is called long period oscillation, right? Anyway, similarly, you can calculate the time to half, can calculate the number of cycle also. Formula I have given to you. So you can do, you can use that formula, and you can get that. N by N1 by 2, N, all those things I have given to you. So I hope you all understood the type of the problem they are asking. Better, now we'll solve one problem. Okay. So the question is, please check it, everybody. The roots. The roots of the characteristics equation, the roots of CE, characteristics equation, for the longitudinal dynamic, for the longitudinal dynamic, please check, everybody. Dynamics, dynamics of a certain aircraft. Certain aircraft are. See, as I told you, they will give the roots. Huh? So for the characteristics equation, they have given roots. Lambda 1. It's not a, no, it's a pair. Check it. It's a pair only. At least lambda 1, lambda 2, and lambda 3, lambda. Yeah, it's a pair. But separately they have given. So there should not be any kind of confusion. 0.02. I need answer, correct answer from everybody. Okay. I hope everybody will able to solve, because similar type of problem just now we have solved. Lambda 2 minus of 0.02 minus 0.2 I. Lambda 3 is nothing but they have given minus of 2.5, okay, plus 2.6 I. Lambda 4 is nothing but 2.5 minus 2.6 I. Check. I will bring it in our format. We have learned this lambda 1 comma 2, which is minus of 0.02 plus minus I of 0. And this will be lambda 3 4. We have seen it's nothing but minus of 2.5 plus minus 2.6 of I. Check, everybody, right? So I won't answer directly without solving anything. Let us solve later on, but at least here, even though without anything doing, you can answer for the correct and for the question. I will write the question first. I need answer from everybody, dear. Okay. So this is very simple actually. Okay, just hold on. Right. Correct. So the question is question number 8. Two question back to back they had asked. This is the gate problem. They had asked the pair of eigenvalue. Please check it. The pair of eigenvalues. Eigenvalues that that represents, okay, the phugoid mode. Represents the phugoid mode. What is the phugoid mode? What is the phugoid mode? Just now we have seen it is nothing but, say, LPO. Agree with me? Yes or no? Option A, lambda 1 and lambda 3. Option B, lambda 2, lambda 4. Option C, lambda 3 and lambda 4. Option D, lambda 1. This is the question. Now coming to question 2. Please check it, everybody. Question 2. The short period damped frequency. What is the damped frequency? What is the damped frequency? Say somebody, what is the damped frequency here? No, I'm just asking what is the notation for the damped frequency? Can you hear me?
0.2 रेडियन पर सेकेंड आएगा ना सर.
Okay, you have calculated, right? Check everybody. So, see, damped frequency. Yes, damped frequency means it's nothing but WD, right? Anyway, check there in the problem itself by seeing they are asking about the phygoid LPO. So if you see the roots for the LPO, I had explained you. If you check the roots, these are the pair of the roots 0.02. First of all, this minus real part of the complex roots is negative. So it means it's a dynamic stable, number one. Dynamic stable or damped oscillation. And if it is the dynamic stable and there is the damped oscillation, so there will be two modes. What are that two modes? LPO and SPO. SPO for short period oscillation, LPO for long period oscillation. That LPO also called as a phygoid. So they are asking in this L1, lambda 1, lambda 2, lambda 3, lambda 4, which one is the phygoid mode root? That is the one question they are asking. Eigenvalue, the pair of eigenvalue that represents the phygoid mode. Phygoid mode means long period oscillation. Long period oscillation means natural frequency should be less, because natural frequency and time period is just opposite. Now see, in which case, if you check it, in which case you are getting lower natural frequency. Huh? Lower natural frequency. I told you that natural frequency you can identify by WD also. So where WD is less, you just compare with the standard. So what is the standard? If you remember, standard I had given minus of zeta omega n I WD. WD is the damped natural frequency or damped frequency, simple. Okay, so WD, if you check, WD is what? Less, time period will be high. Time period high means LPO, long period oscillation, means phygoid. So in these are the roots where you will get the high time period or long time period. Long time period where you will get. Where WD is less, where WD is less, 0.2 we have here and this is 2.6. So this 0.2 is less, 0.2 means that is smaller damped frequency. That means time period will be long time period. So that means phygoid, if you check, you will be getting lambda 1 and lambda 2. So option you have, right? Lambda 1 and lambda 2. Where is the lambda 1 and lambda 2? Check. Lambda 1 and lambda 2. Is this correct or what?
Option D. Yes, sir. Correct, sir.
You have calculated or not? You, somebody, if you want, you can calculate also. Yes?
सर पीछे ऑप्शन डी दिया है सर. करेक्ट है.
Eh? Answer is there?
ऑप्शन डी.
ठीक. And then damped frequency they had asked. For what? For the short. This one you have calculated for the LPO. So don't commit mistake here. So short period means now lambda 3, lambda 4 you have to check. So where is the lambda 3, lambda 4? This is the lambda 3. So this will give the SPO. And for the SPO they are asking WD. So means 2.6. Check your answer. Where is 2.6? 2.6. It's a A. Agree with me or not, dear? Tell me. Say yes or no.
Yes, sir.
Check your answer. Can you cross check your answer?